Okay, you guys, I guess let's get started. I know there's going to be a lot of good information shared. Thank you both being part of this. We're really excited for our speakers this month. I was lucky enough to meet Brook and Jacob at an iDrive event over at the University of Minnesota, and talk to them about the possibility of doing this presentation. And they were kind enough to say they would. And so it's something that to me is so appropriate. I mean, we're so into electric vehicles nowadays, but the team from the U on the solar vehicle project is it's like, to me, another whole step forward. Maybe someday we'll get to the point of being able to drive around in this type of vehicle. But so anyway, if Brook and Jacob, if you guys just want to do a little introduction on yourself. I know when we put it out, I know you're both in computer engineering, and but if you can say a little bit more about yourself, and then we'll get started. Okay.
Yeah, for sure. So I'm Jacob Bunzel, as you can see from my Zoom tag. And I am a senior at the University of Minnesota, studying computer engineering. After this semester, I'm actually graduating this semester. I plan on going into the workforce, trying to use the skills I've gained from this kind of project, a lot of the things I've learned here, which I'm very thankful for in the workforce.
Brook, do you want to jump in?
Oh yeah. Can you hear me okay? Yeah, I'm Brooke. I'm a computer engineering junior. Jacob's taught me a lot of stuff on the solar vehicle project. I've learned a lot through being on here. So I'm interning right now part-time. I'm probably going to do another internship this summer, and then hopefully I can get into the workforce after I graduate too.
All right, thank you. Well, Jacob, why don't you go ahead and get us started then?
Sure. Like Doug has probably said, this is we're part of the solar vehicle project at the University of Minnesota. And I'll kind of give you a little bit of a team overview as to like what the team does year by year. So specifically, we build solar cars from the ground up every 2 years. We both design them and manufacture them, as you can see, both from this CAD drawing and from the picture in the middle. That's actually us doing layups on the carbon fiber and Nomex core of the chassis, or the shell of the car. And on the right picture there, that is our completed E1. So that was actually 2 cars ago, but an example of a car from start to finish. It is completely a student-led organization. We do have one faculty advisor who mostly advises us on more logistical things with the university. But for the most part, we are running everything ourselves, showing up to different races and everything. We actually are, I think, most of the time, the only team without an adult other than ourselves there. Or like a faculty advisor. We're completely made up of students. So it's a really cool organization, and we're all really just here to educate each other and to learn how to build really cool solar cars. So like I said, we race solar cars. We compete internationally, and there's 2 main races that we compete in. One is the American Solar Challenge, which I will commonly refer to as the ASC. And I'll talk a little bit about both of these in a second, but then the other one is the Bridgestone World Solar Challenge. That one is in Australia, and its acronym commonly called is WSC. So I may say ASC, the American Solar Challenge, and WSC, the World Solar Challenge, throughout the presentation. So the American Solar Challenge, the last solar challenge that we went on went from Independence, Missouri to Santa Fe, New Mexico. It was almost 1,000-mile cross-country race, and we did very well at that race. We were the first cruiser vehicle to qualify at this 2021 summer race. And we got first place in a track race. The track race is before the actual cross country race. And then we got second place in the American Solar Challenge, which was the cross country race. So this is actually a really cool photo. And actually you can see me right to the on the left side of the flag from your perspective. I'm the one with the almost bald head. And this is a really, really cool day for us. We kind of designed our battery to be able to travel a little over 400 miles with solar energy. And that day we started with, I think, around 75%, maybe 80% battery. And we then traveled a total of around 356 to 365 miles from our starting spot to a checkpoint in the race. And this entire checkpoint was meant to, by those who planned the race, was meant to take 2 days, and we finished it in 1 day. And so it was a really big day for us, and you can see we're all really, really excited and happy. But it's just moments like these that really, really bring the whole team together, and it's a really cool piece of machinery that we made. The World Solar Challenge, the Bridgestone World Solar Challenge, like I said, is in Australia. And you can kind of see from the picture on the right that this is a lot of vehicles from all over the world. These are the top teams, top universities from all over the world. And it's a really cool experience. And yeah, I will then go into the 2019 Bridgestone World Solar Challenge, which we participated in with our previous car. You can see this one looks a little different, is E2. We were one of the 6 cars to finish the race altogether, and we placed 5th overall out of all the teams. So it was a really successful race for us. And the World Solar Challenge, like I said, is a bit more competitive than the American one, just because the pool of teams and just the level that all the teams are at is much higher. So then the 2018 American Solar Challenge, that was also with E2, EOS to our previous car. In this race, this is again the American Solar Challenge. This followed, I think, around the Oregon Trail route, and we placed first in FSGP and second place in the actual road race. This was actually the first year as well for the American Solar Challenge to have our multi-occupant vehicle class. And I'll go into that different classes in a minute. But specifically for our team history, we actually started in 1990. A group of students and a professor saw the GM Sun Race that ended in St. Paul, and were heavily inspired by this. And so they really, really wanted to build their own solar car. And so what you can see on the screen is Aurora's first race in a GM Sun Race. And this is Aurora 1, the very, very first car we built. As of right now, our current car is, we call it Freya. It is our 14th car. So there's quite a lot of history with this team. And it's a really, really cool thing to be able to look back on the experiences of all these other members and see where this technology has gone, as well as just general, like the education of the students has always been consistent. So I'll go into a little bit about the Cruiser versus Challenger. These are the 2 classes of cars. You might have seen from some of these other pictures back here. You can see on that right photo, there's some bigger cars, whereas there's some cars that are very thin and not very consumer looking. If you can see the one with the orange stripe in it, looks a bit bigger, like a 4-person car, whereas the other ones are thinner, single occupant. So that is actually more or less the difference. You can see this is our current car on the left, Freya. It is a 4-seater, whereas the car on the right, that is one of our older cars. I believe that is Centaurus 2. It is a single occupant vehicle. It's meant to be highly efficient. The ratio between the ratio between output power and input power from the sun is supposed to be much, much closer and it has a smaller battery, of course, and it can go a lot faster because it is a lot lighter and a lot thinner. Whereas the car on the left is more so, its scoring is dictated by more practicality. So a lot of it's like, is this a consumer vehicle that someone would want to sit in? Is this a vehicle that has features that you would see in another consumer vehicle? For example, we have a radio system in Freya, and that's not something you would install in a cruiser because or in a Challenger, the car on the right, because that is more so for efficiency. It's an efficiency race as well as a speed race, whereas the cruiser, like I said, has a lot more scaling towards practicality. We actually have judges on display day come and sit in our car and try and use our radios and all the different features of the car, see how comfortable they are, and they score us based on that. And before I get to that, I just kind of wanted to highlight a couple of the questions that were asked. One was the speed does the car travel? For example, Freya is able to travel between 65 and 70 miles per hour. We've never really pushed it beyond that because we're limited to that speed on our races. And obviously we're not going to try and break anything, if that makes sense. So we kind of kept it at 65 to 70 miles per hour, but it can go on the interstate and has gone on the interstate. Yeah, and then the average speed of the car during the race. So if you're not familiar, you lose a lot more power when you're traveling faster due to air resistance, air drag. So we try to drive at speeds like 40 miles per hour to still get there in a certain amount of time to still try and win the stage in the race, but also trying to conserve energy, as it is still, efficiency plays a big role in your scoring. Yeah, if you have any other questions, otherwise I can answer some now. If anyone has any questions they want to ask in the chat or over the mic. Oh, the solar panels, yes. So let's see, I want to see if there's a picture of this here. So you can see this is our previous car, EOS 2. This is we actually have a team on our project that works on the normalization of the array. And the reason we normalize our array is we want to get it directly perpendicular to the sun so that we get the maximum amount of voltage generated across the solar cells. So how we do that is there's actually hinges on the side closest to us in the picture. And we have these normalization poles that we then bolt onto the underside of the panel. You raise them up, like physically, you push them up, and then you bolt it to the car so that while it's sitting there, it can be adjusted. Those poles are adjustable in length, and so they can be adjusted as the sun starts to fall, or if it's the morning as it rises. Hopefully that made sense. Any other questions? Otherwise, yeah, I have the next thing I'll move on to. So one of the most important things for our team is education and outreach. So both education within our team, one of the things that, or I should say it's the most important thing we pride ourselves on, is educating all of our students. And we take a lot of pride in our onboarding system, trying to teach students as they're coming in as freshmen or sophomores or whatever year and whatever major. We'll teach them the skills that they want to learn and take time to teach them and give them the resources that they need. We have like a lot of office hours for students to come in and just learn things about the car, learn how to program in different languages, and a lot of different things like that. So as well, we do a lot of outreach programs for education purposes. We have a K-12 STEM outreach program. We interact with FIRST robotics groups. We have school visits where we go to schools, or they come to our shop and are able to look at the different things we could do. These are some photos from a school visit, as well as science fairs and like the state fair we bring our car to, and we will try and just inform the public about, where is solar technology? What does it mean for our daily lives? We have a old car, dataless, in the Works Museum in Bloomington. It's a place where kids can come look at a car that really kind of breaks the barriers of what they normally see on the road, and they're able to understand. The teachers are able to explain to them why it has solar panels, what that does for powering the car and everything. So it's a really, really cool educational experience for them. So what is the team doing right now? We just raced our previous car, Freya, in the American Solar Challenge, and we are looking to actually make some upgrades, some internal renovations and external to make the car perform better. And we're really shooting to get first place with Freya in our next race. We're going to be racing in another American Solar Challenge this next summer. So we just raced in one a few months ago, and we'll be racing again next month, summer in 2022. And so looking to make various changes and engineering upgrades and things like that to get us in a better position to win that American Solar Challenge. And I think there's a couple questions in the chat. So one of the questions is, if a car is a 2 or 4-seater, do you have to have that number of people in the vehicle during the race? So you say, or is it just for the design / engineering of the car? So if you have, if you want to be able to drive more than, or I guess a certain amount of people, your scrutineering, or when the judges and the officials look at your car and see if it passes regulations, it needs to be able to meet those mechanical and structural specifications for 4 people, so that the weight that adds, and obviously the sizing of the car for that situation. But in terms of, do we have to ride with those? That is no. We can choose from a strategy perspective, as we're going through the race, if we want to ride with more or less people. The way it works is, in our scoring, there is mileage that we've driven, but actually it's called person miles. So if you drove 100 miles, but we drove 2 people, that's 200 person miles, versus if you drove with 4 people, that would be 400 person miles, and so on and so forth, depending on how many people you have in the car. So obviously, if we reduce the number of people in the car at a certain time, it requires less torque to get the car moving, meaning like it's going to be draining less power from the battery. So and that plays a large part in the different scoring. And obviously, there's a lot of rules behind these kinds of things. But but that's more or less what it is that our scoring will change for that day based on the number of people we have in the car. And then the other question is, I think I missed it. 1 second, my window's a little small. Still not scrolling. There we are. Are there plans to fit bike racks on the solar cars? So for us, on the backside, we don't really plan for anything sitting on the external side of the car. For us, as students, we are working at basically an optimization problem for this particular race. We look at optimizing the aerodynamics, the weight, and the efficiency of the motors to kind of push the boundaries of that. You can more or less think of it as a research project in a way, which allows us just to kind of really be laser focused on those engineering aspects, as that's what we're kind of trying to exercise through our education at school and things like that. So normally we have, or I should say, we do have aerospace engineers here who design the shell to be a very specific aerodynamic resistance. And so adding a bike rack on the back would reduce that. So we would never race with that. There have been talks of having a way for you to add a hitch to the back of Freya as a practicality feature. But of course, we would never race with that, as it would only hurt us. But having that ability to add a hitch would then allow you to have a bike rack and things like that on the backside. But that's a really good question. There are things like that would give us practicality points, even though we wouldn't necessarily race with them, because as you might imagine, it reduces your range. Some of the cars taper down at the back like an aircraft. Some look like they're pulling a wall, or is that just a photographic perspective? So most of them will have a, let me try and see if I can find a picture that shows a lot of them. see. Oh, there we go. So maybe you're talking about these where they both kind of taper off. So for the challengers, normally they are very thin and they will taper off a lot like this. Whereas, and obviously the comfort here is going to be at an all-time low. The passenger in there is very, very scrunched up, holding onto the wheel and barely has room to move at all. Whereas for a car like Freya, to make it comfortable and to give us higher practicality points, we make that interior a bit larger. We still try to taper off, like you can see here, but the frontal surface area is much larger than with the Challenger. And it's a trade-off between practicality, of course, and aerodynamics. With the tunnel here, you can see this reduces the surface area a lot, the frontal surface area, allowing us to get a lot lower aerodynamic resistance or drag. And that tunnel kind of like runs all the way through. It's just an opening under the car. But yes, you are correct that there is quite a bit of cars with this more or less like teardrop shape with these larger cruiser vehicles. A lot of the Challenger vehicles are able to get away with kind of just like a pancake almost style car because they're not going for practicality. Let me step back to where I was. If that's it, I think that's all the questions. Yeah, awesome. Yeah, like I said, if you guys have more, if I didn't explain something to a point where you understood it, let me know. Definitely let me know. Team structure. So I'll go over a little bit of like what our team looks like internally, just to kind of give you a perspective of all the different things that we make, which we make almost the entire car ourselves. We're made up of kind of a engineering division, which contains the mechanical, electrical array, and composites and structures. And I'll go into each of those in a second. And then our operations team as well, which deals with a lot of the logistical parts of the car, of the team. Before I move on. Okay, yes. How does your car compare to a Lightyear one that is going commercial? So in comparison to a Lightyear car, our car is going to be a lot lighter. Lightyear is trying to go commercial, which means that it needs to follow all of the transportation regulations, safety regulations. So for example, it needs to have, sorry about that, my headset fell asleep. So it needs to follow all those regulations. And so for example, it needs to have all these crumple zones, as well as like all like rollover risk and rollover prevention, or I guess safety, rollover safety, as well as like side airbags, which adds up a lot of weight. Whereas with our experimental cars, they don't have things, these things. We do have a roll cage, which does protect the driver, but they also are wearing a 5-point harness as well as a helmet. And there are no airbags in the front. Normally our car drives in what we call a convoy or caravan, which has a lead and a chase vehicle with the car in between, and that protects it and the drivers from other vehicles driving on the road. As well, they have like lights on top to show that there is a car that could be going slower than the speed limit and things like that. But those are the major differences between this and the Lightyear one. Obviously, we're also not designing our vehicle for manufacturing, which is a big difference. As most of you probably understand that manufacturing is 50%, if not more, of the challenge of creating a commercial product. So that's something we don't have to worry about. We have to worry about how we are going to manufacture it as students, which is a big challenge as well, because we're on a very, very tight budget, as well as we're limited by the machines and the time that we have to make these things if we're making them in this kind of timeline. I mean, we're students as well, so we have to go to class and everything, unfortunately. But how do you decide on which style car to race? So for the first, let's see, 10 or so cars, we were Challenger. And a lot of that was because when these solar challenges started, that was all there was a Challenger class, which is that smaller one I showed earlier. The one on the right, that's all they had for these races. And so actually, we kind of inspired and pushed the American Solar Challenge officials to add the cruiser class. The World Solar Challenge had added it before the American one. And so we actually raced our E1, which was a cruiser class vehicle at ASC, the American Solar Challenge, even though there wasn't a cruiser class at the time. And so we did not win because we weren't as efficient as the Challenger, but it was kind of a statement to say that like this can compete and there is a place for this in this race. And I think there are teams interested in everything. For like from now until however many years in the future, we are going to almost 100% stay with a cruiser vehicle. The thing we really like is the amount of engineering aspects that hits. In a Challenger, you're going to be optimizing certain mechanical perspectives as well as electrical perspectives, but there is a place for practicality that is a big part in obviously the industry and educating students. And it is a different design challenge along with the optimization. So it's something that our team is big enough that it can take on that challenge of having more levers to pull and push with practicality and everything. So it's something that we really enjoy, having that uniqueness to a car where you have different practicality features and things like that. Yeah, hopefully that explains the, or that's a answer that makes sense. Do you redesign the cruiser from the ground up every year, or do you modify the original car? It depends a little bit. This is a good question. Freya, the car on the left, the 4-person car. This is a first 4-person cruiser car. Previous cruiser cars had been 2-seaters. So this one actually took us about 4 years to design and manufacture. And so normally we do this in 2-year cycles so that we have a year where we're designing a car and then a year we're building the car. And then we race that car for 2 races, one ASC and one World Solar Challenge. So we usually redesign the cruiser from the ground up, obviously learning a lot from the previous cruisers and previous challengers as well. Or like we are doing this year, we are deciding to race Freya in the 2nd year. A lot of the races and the timeline of the races has been messed up because of COVID. The World Solar Challenge has actually been canceled for the last 3+ years because of COVID, or I think 2 years. The last two were canceled. So they won't have another one until 2023. So that's been kind of changing our plans as well, and obviously affecting our lab time and everything for working on the car. But for the most part, normally every 2 years, we make a brand new car. Like I said, there's a bunch to learn from all these things. And like Brook just posted, there on our website, we have a lot of information on the different cars we have. So let's look at a little bit of just the different teams, walk through this pretty quickly. Like I said, we have the engineering sub-team electrical, where we deal with a lot with the battery, the center console and dashboard, and the light system, all the electrical aspects of the car, as well as a lot of those practicality features that are interactive with the user, like the dashboard and center console are more or less infotainment systems, like you would see like in a Tesla, or just like the general controls of your car and things like that. We then have the battery, obviously is built by the electrical team. But one thing I'll note is that this project of building a battery for the car takes a lot of different systems. Obviously, it takes there's airflow going through it, so a lot of aerospace engineers have a lot of input on that. The air needs to flow through the cells so that they can cool off. As many of you probably know, batteries start on fire when they get too hot, but also they can become damaged and start on fire if you get too high a voltage or too low a voltage. So electrically and from a software perspective, we have to have a battery management system to kind of regulate all of those things. As well, there is a mechanical structures perspective of having this box and this battery to be able to withstand various like vibrations and a certain amount of G's within turns, and even an accident, we have to, per regulations, have it rated to withstand certain amounts of forces. Looking at the mechanical team, we have a lot of finite element analysis, as well as just general like CAD design. Mechanical team for us deals a lot with the moving parts and the controlling parts of the car. So the suspension, motors, brakes, steering, wheels and rims. And you can kind of see like a CAD drawing over there of our Freya, both A-arm design as well as the rim and motor attachment. Looking at composites and structures, this deals a lot with the aerodynamics. So computational fluid dynamics softwares are used by our engineers. A lot of that every 2 years we'll design a shell and we'll vote on different shells that different engineers make. There are different perspectives, like obviously the internal like space that there is, as well as the big number, which is like the actual coefficient of drag that the particular shell has. And then as well, this team deals with the structures. So the shell design is the aerodynamic part, and then we have the roll cage, which is a structure, the chassis, doors, windows, and where the lights get mounted and how they're mounted. So dealing with a lot with that as well. The array, one of the most obvious things that are different about our particular electric car is the array and our ability to convert solar energy into battery power and then to change that into kinetic motion. So we directly manufacture our array from the individual silicon wafers. We work with 3M as well as have engineering professors here that help us learn about the best way to encapsulate these and work with the different film that we use to encapsulate these. There's obviously a great interest in our team for furthering the knowledge and education of sustainability. So the array panels are a really, really big way for us to do that, as well as obviously the electric nature of our car. And we deal a lot with the research and development with the different semiconductor characterizations where we can source these wafers from, as well as the circuitry that we use to track the power. Some of you may have heard of maximum power point trackers, which try to optimize which cells are currently being used to generate power. This deals with a lot of like simulation, of course, before we actually design the solar cells. We're able to simulate various parts, various designs of the array, as well as different ways that we could assemble the array together. Talk a little bit about the operations team, which is a very big part of our team as well. As you can imagine, building a car like this costs a lot. So the finance team has to create budgets, apply for grants, and work with the purchases and inventory that we have on the team. The social media and marketing, obviously that's the face of our group. They work a lot, really hard on getting good photographs of our car during race, as well as while we're building the car. And they manage our social media accounts and newsletters that our various fans and sponsors look at. So this is a lot of cool things that these students get exposure to. There's a lot of events we do, both domestically and internationally, as well as, like I said before, the sponsor visits and K-12 outreach programs. We then have a large portion of that is sponsor relations. So dealing with getting our resume packets and sponsor information to our sponsors, as well as communicating and networking with those sponsorship companies. And kind of talking about that a little bit, our donations and sponsors. This is more or less, we're completely funded by some of the school, obviously, and the grants we get, as well as the companies that want to see our team go further. Let's look at the questions really quick. What happens to the cars in the long term? Do you keep them? So we keep some of them. So currently we have EOS 1 and EOS 2 in our possession, along with our current car, Freya. So that's 3 cars we have. Otherwise, like I said, there is one of our older cars, Daedalus, in a museum. There are sometimes alumni who will take them and bring them to a museum as well, and different schools. And so we try to bring them to a place where they will continue to educate students and educate younger students as to where the world is going in terms of the environmental and sustainability, as well as electrical aspects of engineering. And so that's something we really try to do. Like I said, we're a very educational group. That's our highest priority. Obviously, winning races is cool, but the biggest win for us is being able to educate students of all ages. And as time goes on, like we'll build another car, and we'll get rid of EOS 1 by giving it to a school or a museum or something to that effect. Do any of your students go into the auto industry? Yes. So we've had various members go work for companies like Polaris, and there's a few students who've actually gone to work for companies like Tesla, as there's a lot of application here on the electrical side of things, and structural, dealing with having a battery in your pack and things like that, or in your car, is a design challenge. So yes, definitely. A little bit about donations from individuals as well as sponsorship companies. We have quite a few of them. As I said, these cars are very expensive to design and manufacture. And so we have a lot of companies that are super, super gracious to give us various parts along with software and cash donations. And so we have various stickers of these companies on our car, as well as currently the back of my shirt has this on it. And so we're super, super grateful to all of our sponsors and all that they do for helping educate all of our students. So kind of why do a lot of these companies sponsor us? And I'll step into that a little bit. Obviously, a big part of our organization is protecting the environment. This car isn't necessarily, the cars we make aren't necessarily made to be manufactured efficiently. They are prototypes, more or less. But what we are doing is that we are emphasizing practicality, efficiency, and creating familiarity among the public with what these solar cars, when produced for commercial purposes, would look like. Getting them used to seeing that and thinking that, this is pretty cool, is kind of the thing we go for, as well as stimulating the boundaries of what sustainability can do by trying to make these optimizations that we do through our competition. As well, just bringing generally the solar power into the public eye. Obviously, when in the 1980s and 1990s, when these races started, solar power was a very, very rare sight. And through programs like this, through education programs like this, as well as solar panels have gotten a lot more efficient and better, we've brought this more and more into the public eye. And that's something that we want to continue to do, as well as educate our students to go into industries like this and use this expertise that they gain through this program to create more efficient solar panels and create electric cars that will be successful commercially. Another thing we do is we invest in the future workforce of these companies. So a lot of the companies we work with have parts that are and products that are similar to what would be used in an application like this. So a lot of them are investing in students that would be future employees. And so we have over 100 students in our program, both from computer science and engineering, as well as the operations side of our team has students from all over the university. We even have students in the engineering groups who aren't necessarily engineers, and they're providing really, really impactful feedback or work towards the car. And so we're willing to teach anyone and get anyone up to the point that they want to provide work towards the team and the car, and just allowing anyone to have that impact on our project. As well, we teach students time management, teamwork, obviously, with 100 students, and as well, kind of taking the curiosity and going with it. There's a lot of upgrades that we make to our cars every 2 years. I know someone asked this before, that we remake our cars from the ground up, and part of that is educational. Actually, a lot of it is educational, because the students get to take what they learn from the car that maybe when they joined, that car was around, and saw what was good, what could be better, and take that and take their curiosity, learn about new things, learn about new technologies that are out in the world, and push those boundaries. We teach a lot of the students about softwares that are commonly used in industry. Some of you may have heard of like Creo, Altium, there's like SolidWorks, ANSYS, all kinds of different programming languages that we use on the electrical software side of things. And in general, just real world engineering that companies are looking for, management experience through our operations, and being able to deal with talking with a lot of different teams. As you saw, we have a lot of different subsystems and sub-teams, and we all need to interact daily. We also attract competitive and skilled students to the company that sponsors us. So students will come and join this group if they are really, really curious and really driven to do this much work outside of class. And so investing in students of this caliber and this like amount of just curiosity is really beneficial to a company. So I'll maybe take a couple questions real quick. I see a couple in the chat. Yes, it is very cool. Ben mentioned responding to us building new cars every 2 years. It is a really, really neat experience for us. A student being able to see a product from the design stage all the way through to the, hey, we're going to use it to race against other teams stage. It's something that you don't get a lot at working in industry even, because a lot of times you're kind of in the bubble of like designing something, but we give them perspective of that entire process. And even making, like, not making is a poor word, but we design the car with our hands a lot of times, going in and doing those layups and design, or actually constructing the chassis and things like that, really seeing those different trade-offs right there in first person. The male to female ratio, it's very, very similar to what the the College of Science and Engineering has. And we have a, I think, 25 to 30% ratio of females to men. And we really try to make this accessible to anyone in the computer or the College of Science and Engineering, as well as the operations team. Do the schools share information on their builds after the races so knowledge is shared at a larger level? So actually, this is one of my favorite parts of going on a race and going to talk to other teams, is that, for example, at this last race, we communicated a lot with other teams, and there were times where other teams were struggling to get something working. During our scrutineering stage of the race, officials are looking at our car and making sure it passes regulations. And so we take time to help other student groups that are maybe struggling to get something to work. We'll go over and offer our expertise. Sorry about that, it fell asleep again. As well as them doing the same for us. We'll have like an electrical problem, they'll maybe offer us some equipment and vice versa. And it's a really, really cool thing to see that even though, sure, we're competing, but we're all really students in the end, and we all just want to learn how to learn about cool new things and things like that. So we're all really good about sharing information and talking to each other and having a lot of fun. But when it comes down to it, we all kind of hang out after the races and after scrutineering and talk with each other, and it's a lot of fun. So another thing that companies will sponsor us for and really like is that we're also inspiring the youth, kind of taking that education we're getting and passing it down then even further. Like I said before, a lot of hands-on experience for younger students, the K-12 outreach program, and like I said, the Car and the Works Museum in Bloomington. And kind of as a summary and a reminder, the companies really like us seeing us do well and having fun on the race. A lot of it, as you might imagine, an employee who really enjoys their work is going to work a lot harder and get a lot more done when they're having fun. And as you can see, we're all having a lot of fun in the photo on the right. And this is us with on the track on the left with all the other teams around us cheering on our team. And as well, like I said before, our place on the track race was first and the road race second place. We also won events like the safety award meant for a team that was went above and beyond into making things safe within their car, as well as the Spirit of the Event award, which is a really cool thing for us because we really take this race both seriously and we really have a lot of fun with it. So it's a really cool experience, and our team has a lot of bonding because of it. So I'll step to this last slide here, where you guys can ask some more questions. As well, if you're interested in learning more about donating or sponsoring our group, or just following us on social media, we have a Facebook and Instagram. The tag is UMN SVP for University of Minnesota Solar Vehicle Project. And so follow us on there if you want to follow our progress through our races and our build cycles. It's really cool to watch. And like I said, these are the links for learning more about sponsoring and donations. As well, you can learn more general information from just going to umnsvp.org. That'll have a page with links to the cars and the donation and sponsor pages, as well as more. Yeah, so now I'm kind of open to questions, so you guys can ask via the chat or
Jacob, do the race courses change every year, or do they stay the same?
Yeah, so they do change in the American Solar Challenge, usually race to race. There are times, I believe the 2022 race will follow a similar route to the 2018 race. And so they sometimes like do a similar route, but we'll try and change it up for the American Solar Challenge. Obviously, the one this last summer was not along the Oregon Trail at all. It was from Independence, Missouri to Santa Fe. And so they'll sometimes change them up and then sometimes they'll kind of repeat years, because obviously students are only around for like 4 years. The World Solar Challenge is a fairly constant route. It actually goes from the north side of Australia to the south end, the continent itself. So that is a little over 2,000 miles actually, and that's a pretty consistent route. Let's see. Corporate enterprise should learn the sharing lesson. I agree a lot. I think it's really, really fun for us to have that ability to share with other teams, and like everyone benefits from it, obviously. For the two races, do they block off the roads, highways for the race, or are you driving with everyday drivers? We are driving with everyday drivers, and that's kind of the reason for that convoy that we have, the caravan vehicle in front and one behind, to protect our solar car and to kind of warn drivers that I mean, you can kind of think of it as like the wide load semis, kind of warning drivers that there's a potentially slower accelerating car, as well as just something different is going on to be aware. And then Pete, you asked, are solar cells single crystal silicon like most of us use, or is it something that only NASA can afford? So we use a lot of solar cells that are of the highest efficiency, but we are using silicon, and it is something that you can buy commercially. In terms of what people normally buy for their homes and everything, they usually probably buy lower efficiency cells unless they have the money to buy something. It's not obscene costs, but it is a bit more expensive to buy the silicon that we do. The things that NASA uses are like gallium arsenide, and that is actually, gallium arsenide is banned in the World Solar Challenge due to the nature of arsenic and the cost. They try not to limit the teams that can participate by cost too much. Obviously, this is pretty expensive, but having teams have to go and buy gallium arsenide to compete with teams that have it would be pretty unfair. And so they do that for both a safety perspective as well as a competitive perspective. So for us, it's going to be cells that most of you guys use, but a bit more efficient, maybe a bit more expensive, depending on different use cases that you guys have.
Jacob, we might have an opportunity for you. So we've been asked to demonstrate STEM and solar boats at the Minneapolis Boat Show. So we have a huge area that we need to fill, and we'd love it if you could bring 2 cars. And so that's actually January, I think 20th through the 23rd.
Yeah, we'll have to
show us your car there, and you could advertise your STEM program.
Yeah, we'll have to communicate with the operations team and figure that out. Usually during the winter time is a tough time for us because we're making large like mechanical renovations to our cars, and it's also harder to get them out of where they are. But we can definitely talk to them about that. Yeah.
Yeah, good way to show it off to 30,000 people, you know?
Yeah.
Jacob, do you, what's the average amount of time that the students put in on this? Now, you said it's in addition to their classes kind of thing?
Yes. So this is something that we all do outside of our classes. It's more or less an extracurricular. The hours spent per week, I guess, it varies quite a bit by student. There are some students who like to participate in like research or other clubs on top of this as well. And so they might spend, something like 3 to 5 hours per week, something like that on various coming to meetings and things like that. And there are certain weeks that students have like exams and don't come to various meetings and have a week where they work a little less. Otherwise, there are other students who really, really enjoy this. I for example, can spend up of like 10 to 20 hours per week working on these things, as I really enjoy working on this stuff, and I find it equivalently educational in comparison to my both my internships that I've had as well as my classes. There's a lot of unique things to learn here that a class obviously cannot, or a course cannot obviously provide. And so it's a really cool experience. And so there is that ability for students to spend as much time as they want to get out of it. But we're here to educate anyone who wants to participate any amount of time.
Are you still working out of the St. Paul campus?
So we have a shop in St. Paul where we do a lot of our like mechanical and manufacturing work. We're actually currently in Shepherd Labs at the university, which is where it's on campus, on the Minneapolis campus. It's fairly close to Keller Hall. And this is where we do a lot of our electrical work. It's more of a cleaner area where we don't do a lot of manufacturing, so there's not like sawdust and like metal fragments all over the place. It's a cleaner area where we can do our manufacturing of like our printed circuit boards and things like that. So we have a location here as well, which is super, super awesome. It was actually donated to us by a past advisor, a professor who actually helped start the organization. So it's super cool.
Have you kept history of the events? I went to the first one when the team came into the Minnesota Zoo way back when, and General Motors had their new electric car out there at that particular one. I mean, is there stuff that you have like online or anything that shows the history?
So our website, umnsvp.org, has the history of the various cars and where they raced, how they did, and some of the information about the events. Internally, we have a lot of history of just like the engineering perspectives of our various cars. On like our various servers, we have like, oh, how was this designed and things like that. But for the public, we have information about all our cars and things like that. And if that makes sense. Yeah, we have a lot of history on that website.
Yeah. Thank you.
And I think on our Flickr as well, we have a lot of photos from a long time ago and things like that.
I have a question. You might have actually answered it, in which case I apologize. I missed the beginning of this, but the supply chain problems that are causing so many problems with commercial cars, has that affected you?
It is very heavily affected us. A lot of it is because we're not ordering in bulk, and a lot of companies that are ordering in bulk maybe had their orders set already a long time ago, and they maybe have a certain amount that they're working with. Whereas we as a team are ordering a small quantity as well. We are always changing the like parts that we use from the electrical side of things. We're trying to like upgrade our systems and things like that. And so currently we're actually changing a bit about our BMS system, our battery management system. And we are struggling to find various parts that we need. It's really, really awesome that our companies, our sponsors, work with us to get us parts that maybe are out of stock, but they really want to continue to push forward our project. And that's super, super awesome that we get that from them. But from a general perspective, we get hit we've gotten hit a lot by that. And it's an interesting engineering challenge to design our boards to work with all these different kinds of chips that we're not used to working with. So it's pretty cool. It's a unique experience, but obviously not one we'd rather have.
Right. Yeah.
Yeah.
Okay. Thanks.
Yeah.
Any other questions or Brooke?
Yeah.
Brooke, do you have anything to add?
I think
Anything that
Jacob-
you guys have been able to patent?
You said patent?
Yeah.
Yeah, so actually, some of our students, not necessarily patented directly off of what they created, that solar vehicle, but there have been some members who've gone off and created things like a maximum power point tracker, for example. And that's actually one that we use. It's called, I believe, the Photon 2. It was created by an alum who graduated and then took what they learned from the solar car. They were actually developing maximum point trackers, power point trackers, when they were on the team, and then they made an iteration after they left, and so that they got a patent on that. Directly from within the team, we don't normally deal with those kinds of logistics in terms of like the time consumption and complexity of getting a patent through the university. Is pretty tough, and we move at a pretty fast pace. But there's definitely been a lot of alums who've taken their ideas and different things, products they've made on the team, and furthered that beyond the just the schooling.
Brooke, I'm back to you. Anything from you?
Yeah, I think Jacob covered everything. We're just super happy to like be able to participate on a project like this. We're super grateful to all the generous companies and people who make it happen, and to the people like you who are interested in it and supporting us. So thank you for having us.
Awesome. Well, this has been great. We really appreciate you guys doing this. It's just, been very educational, and to me, it's a very exciting thing that the U is involved in. And is there anything, Jacob, that like if you were to wave a magic wand that you would like to see added to the program that would make it even better?
Let me think. Wow, that's a big question. I think just larger, maybe just sight of the program from a student perspective. I think personally for me, this program has been probably more impactful to my education than like, for example, internships have been, because the amount of hands-on experience and the amount of time I spend over the 4 years that I'm here is just huge. And so I think getting a lot more like public vision and as well as support from the university is always welcome. They give us a ton of support as is, but obviously it's always cool to see more, because I think this is something that creates some of the best engineers that come out of the engineers and other majors that come out of the U. I've met a lot of really, really smart and passionate people who are just really want to learn and like create the next cool thing coming out of this program. So I think it's really beneficial to the university.
Yeah, that's awesome. Any other questions? This is a great chance to ask them if you have them. Well,
what manpower support could MRES provide that's of use to you?
I mean, more or less just public broadcast, right? I guess informing other people about these technologies is something you guys are already trying to do, and that's awesome, because one of our biggest objectives is obviously to educate not only students but the general public as well, and that's something you guys are already doing really, really well. And so the more that people get used to that and accept it as kind of our future, the more that like their companies and things like that will come to see our groups as both successful and something that they should invest in. So I think you guys are already doing that a lot. Obviously, donations and sponsorships from the various companies you guys have worked at or work at right now is huge for us. Just being able to get us to get that next cool part or design the next part of the car that we want to build.
Perchance, do you have like a 10 scale model of it that we could show at some of our events?
There are I think. I don't
Something that
think
fits in an
we.
Equinox.
Yeah, I don't think we have any models like that. A lot of times we struggle to get the actual model done. That makes sense. But we don't have anything like that. We have a lot of great pictures on our website that show both our current and past cars. But anything from like a model, no, we don't have, unfortunately.
Jacob, you have like video clips or a PowerPoint of your cars in action that we could use on a loop. You know, like we have.
I think we could send you. Yeah, we could definitely send you some.
Yeah, put it on a file and then run it on a screen.
We also have like file slides, and we have some YouTube videos that we could run on a loop. We have some like folders of like pictures that we use as like at various events that we go to that we just kind of put on a loop to kind of show the different aspects of the races in the car. Yeah, there's some cool videos out there. I think Brook is going to paste one in the link that's just available on our YouTube. So it's right there in the chat. So if you are interested in any of that or using that, you can also, I think, look on our website. Like I said, we have some really cool stuff there. The website links to all of our like Flickr, which has a lot of our photos, as well as to our YouTube, our Instagram, which has a lot of the media that we even have as a group altogether. So.
Have you had any breakthroughs as far as like batteries, since you know, a lot of utilities and are going to battery backups for solar generation around the country? Obviously, there's only so many finite resources and things like that. Have you guys had anything come along those lines?
Yeah, so from a chemical perspective, we obviously don't do a lot there. That's a lot meant for like researchers and things like that. We use commercially available lithium ion cells. Actually have one right by me. It's like these, something that a Tesla uses and a lot of other electric cars use lithium ion cells. But what we try to do is we try to really optimize our like BMS and electrical systems to as well as structural systems to kind of get the most amount of power out of those. And we take that knowledge when we go to other companies, and they're doing a very similar thing. We provide a lot of insight to that. So in terms of breakthroughs, I'd say a lot of it's going to be optimization, us optimizing how much power and how much efficiency we can get out of these cells and things like that, both through the electrical design and like the design of the shell to reduce drag and things like that. If that answers your question.
It's a very good answer. I mean, I guess two of the biggest barriers for taking a lot of the knowledge that you're utilizing to make a really cool car, which is going to be needed, is on the power sector is the amount of solar cells that it takes to generate, like, let's say a megawatt of power, and then be able to back it up with power batteries so you can keep that supply going well after dark.
Yeah, definitely. It's definitely a lot of stuff we deal with as a team, like power cycling and capacity degradation and things like that. Very, very interesting topics, definitely.
You bet. That's awesome.
Yeah, so I think this is about time for us. We got to head out and run some other events with our team members. So like Brook said, thank you so much for having us. This has been really fun. And the questions were really, really cool, really good. We love answering questions about stuff that we're super passionate about. So thanks again.
We really thank you for taking the time to do this. This has been great. And we will take the video that we captured and post it up on our YouTube. Awesome. And then share that with our members and everything. And it'll probably take a 3 weeks for that to happen. So, and the only thing else I wanted to mention to others that are on the line right now is next month, our speaker will be talking about a product called Solar Suitcases, which is part of the Solar on Schools program going forward, the educational part. And so we're going to be talking about that. But anyway, thank you so much, Jacob and Brooke, for doing this. And we'll look forward to talking to you along the way.
Definitely. See you guys. Thank you.
Yeah.
Thanks.
Great job. Thanks for coming and presenting.